All right, Bismillah Rahman Rahim. This is the binary coded decimal. We did talk about it, what and why we are using this to review that in digital clocks and at any place where you can see that digital numbers are coming or displaying on a screen. These are with the help of binary coded decimal. The good thing in the binary coded decimal that it is going for the precision, which means that once we are dealing with decimal points and decimal places, this will come up with, in computing, this will come up with a very precise and accurate result. Otherwise, the other data types we are using in the programming in floating point, they might not come up with the precise and accurate result. So how we are going to change it in the binary coded decimal, we have a number of examples over here. Number one, this is 6 and 2. We are going to split this 6 and 2 separately. In binary, we are doing it like 62 straight away, but as you can see, that table is already there, and we are going to do it. So let me make this 2 first, for which I just need to place 1 over here, and rest of the things are 0. And for 6, I need to place 2 1s like this, and the 0s. Then we have 35. I'm going to make 35 first, and then 3. So altogether, what we need to do is to check the answer, and we need to do it from the extreme right. So as you know that 0 and 1, and once we are going to add it, the expected result, by the way, this is 97, and we need to come up with 97. Let's see if it is going to work or not. 1 0 1 0 will become 1, and 0 1 will become 1, and the 0 0 will become 0. Okay, this is inside the range still, means 4 plus 2 plus 1, which is equivalent to 7. So the answer is coming on this actual bit, nibble is absolutely right. We need to make it as a byte. So the next one is 1, and here we need to go for carry out, another carry, and I'm going to place this 1 over here. So this is altogether, this is 9. So 9 and 7 is there now. This is it for the 1. Now the next one is we have another example over here, which is the number 64 and 45. Let me start it from here. We might need the third place. So let's start it with the 4. To make it 4, we just need to do certain things like this. And let's make 5 as well. This 5 I'm talking about. So for 5, I need 0 over here, 1 over here, and 0 over here. Now 6 is absolutely very straightforward. And 4 is, again, we don't have too much trouble with this one. Okay, let's add them together quickly. So this 0 1 will become 1. This 0 0 will become 0. This 1 1 will become 0. And we are carrying out 1, and this 1 is coming out over here. So 9 is the result, 8. 8 plus 1, 9. And this is our expected answer was for the first octet, first nibble is 9. Okay. Next, move on to the next one, 0. Here we have 1. Just because of the 1 is over here. Here we have a 0. Carrying out 1 and 1. So now, as you can see that the answer basically is coming with the 1 0, which means 8 plus 4, and sorry, 8 plus 2, which is 10 accurately, understandably, but there is a flaw, there is a problem over here. Yes, we do have 1 0, but what the problem is? The problem is, please do understand it clearly that we have 1 over here. If I might copy the certain situation, seems like everything is okay because it's 10, but it is not, basically. What is happening if I am going to place 1 over here, 1 here, 1 here, and 1 here? This is binary coded decimal. In the decimal number systems, we only have 10 digits starting from 0 to 9. But if I'm going to calculate all these numbers, and most probably if I might have certain situation like this, so if everything is 1, so this will become 8 plus 4, which is 12, 12 plus 4, 12 plus 2, 14, and the 15. So answer is 15, which is not basically available in my denary numbers. Getting it? So means that we do have spaces available for something. That is what we don't need to. Now, as I said that this is something not accurate, so how can I make it as accurate? If you can see the difference between this 9 and this 15, this is absolutely, if I'm going to place a minus sign over here to make it, excuse me, to make it till 9 at least, what we need to do is to either subtract 6 from here. So this 6 is very important now. And this 6 is going to do the certain magic. And that magic, here you can see that the octet we have over here, 6 and 4, will come up with a 0, where we don't have 0 over here. So let's try to make a binary for the 6, which is very easy, 4 plus 2. And let me place zeros over here. And now we are going for the answer. Let's see if it is going to work perfectly or not. Let me track down things a little bit. Okay, 0, 0 will become 0. Again, we are adding now these numbers, these two numbers. 1, 1 will become 0, and we are carrying out 1 over here. I don't have a space, but you should imagine it that 1 is over here. So 1, 1 will become again 0, and 1 is carrying out. 1, 1 will become 0, and 1 is carrying out here. And now you can see once I'm going to write 1 over here, which means 1, only 1. So this is now the third area, which is going to open with the 1. We do have answer of 0, and we do have answer of 9 as well. So definitely, as you can see that this is little bit trickier now. Wherever we have answer more than 9, we are going to place this 6-bit pattern over here, which is the error correction method in binary coded decimal. Now let's see, we have another huge number, which is 689, and we are going to add 954 on it. So let's see if it is going to work. Let me make 9, 1 here, 0, sorry, let me do it in this octet. So 1, 0, 0, and 1. To make it 4, it is very easier one. I'm talking about this 4. So shifting it over here. Now 8 and 9, I'm going to write 8 and 9 in binary coded decimal. right now. 8 and sorry, 8 and it was a 5. So starting with this one, 5 is now written. 6 and 9. So 6 will be 0, 1, 1, and 0, and 9 will be 1, 0, 0, and 1. Now let's see if it is going to work perfectly or not. We need to add these numbers, starting with this one. 1 is coming with a 0. We have 1, and we have 1. So altogether, as you can see, this is 8 plus 4, which is 12. And there is something wrong over here. It means that this is out of range, right? We have a range till 9 only. So what we need to do is to add that particular 6, which we were talking about previously, that is going to correct the error. So let me write it over here, 0 and 0. Let's go for the next one. Let's see if we have same result of what? Okay, 1, 0, 1, and 1. So we have another issue over here. The same number is coming, and we need to add again 0 and 1, which is 6 over here as well. Let's see, is this correct or not? 1, 1, 1, and 1. This is also incorrect. So we need to add 0, 1, 1, and 0, which is 6. Let's see what is now upcoming result of this particular thing. So 1, 1 will become, excuse me, 1, 1 means we have 0 over here, and let's carry out 1. Now I'm going to see these two numbers and going to look for the carry out operation. So 1, 1 will become again 0. Excuse me. This was we were trying to do it from here and then here. So excuse me for a while. This is there is no carry right now. 1 and 0 will become 1. Then 1 and 0 will become 1. This 1, 1 will become 0, and we are going to carry out 1. And this 1 and this 1 will become 1, 0. So I'm going to write 0 over here and carry out the thing into next nibble. Now we have to see this one and this particular one. The problem is that this is 1 and this is 1, so we are going to write 0, and after the 0 we need to write 1 in the carry operation. So again, 1 is here and 1 is here, which will make it as 0, and we need to write a carry operation, which is 1. So right now I have 1, 2, and the third one is in blue color. So which means that I am going for 1 and carry out 1 again. Now I need to see this particular area, 1 and this one. So I have a 1 in the series, which will make it 0, and 1 is carry out over here. 3 ones straightforward, which will make it 1 and 1. 3 ones is straightforward again, will make it 1. Right, again, there is a trouble. What I have done, something wrong. It is 1 over here, and I need to see these two elements and this element. which means I need to write 0 over here, and 1 is going to carry out. All right, now here we have 2 ones over here and 1 over here, which means that I need to write 1 in this block and carry out 1. Again, 1, 1, 1. 1 I'm going to write in this block, and 1 I'm going to write on this block. I have carry out operation 1, and here we have 1 again. So this means we are going to write 0 over here, and this carry might forward it to the next one. So straightforward, I'm going to write this one here. Now, if you can see that what is the result of this octet, this particular nibble. This is 3. So we have 3 over here. This is absolutely a simple 4. We have 4 over here. This is absolutely 6. 4 plus 2. We have 6 over here. And this is 1. So we have 1 over here. What you need to do is to fill up the spaces. Mind it that I don't have a space over here, otherwise I need to fill up this space with 4 zeros as well. This is the first nibble, second nibble, which will make it as a byte, and I need one more thing for the byte. Here we have complete byte. There was no issue at all, and here we have another 2 different bytes over here. One block is this one, and one block is this one. So we don't need to add any other nibble or bit. That's it. Thank you very much. I hope this is quite understandable. Thank you very much. Allah Hafiz.